Good morning, students. Today we are going to discuss the assertion and reasoning based questions. Assertion and reasoning questions is introduced by CBSE in 2021 CBSE board examination. The 4 questions will be asked on assertion and reasoning type questions, right? So today we are going to discuss the few assertion and reasoning based questions related to the electromagnetic induction, right? The first question, first of all, we should know that how to answer. There will be 2 statements. One is related to assertion and other one is reasoning. If both are correct, means the assertion is correct and reasoning is correct, and reason is the correct explanation of assertion, then there will be answer 1 or option A. Option 1 or option A, right? If both are correct, but reason is not the correct explanation of assertion, then the option will be B or 2, right? If assertion is correct and reasoning is wrong, it means the option is C or 3. If both the statement means the assertion and the reasoning both are wrong, then the option will be D or 4, right? So this is the first question. Total induced EMF in a loop is not confined to any particular point, but it is distributed around the loop in direct proportion to the resistance of its part. Now the reasoning in general, when there is no change in magnetic flux, no induced EMF is produced, right? Now both the statements are correct, but the reasoning is not giving the correct explanation of assertion. Assertion is also correct, reasoning is correct, but reasoning has no relation with assertion. So option B or option 2 is correct, right? Question number 2. The induced current flows so it opposes the cause produce it. Reasoning, Lenz rule or Lenz law is based on conservation of energy, right? So the reasoning is giving the correct explanation of the assertion. So answer A or 1 is correct, right? Now Faraday law is an experimental law. This is the assertion. Time varying magnetic flux cannot generate induced EMF. Now you can see that reasoning is not correct. Assertion is correct, since the time varying magnetic fields also generate the induced EMF. Here is cannot generate, right? So the reasoning is wrong, but answer assertion is correct. So option C or 3 is correct. Now 4. The mutual induction between 2 coils infinitely apart is 0, right? Mutual induction between 2 coils infinitely apart is 0. If the mutual induction between the 2 coils is 0, it means that there is self-inductances are also 0. So reasoning is wrong, assertion statement is correct. So its answer should be C or option C or 3, right? Question number 5. An inductor is called inertia of electric circuit. Assertion, the reasoning, an inductor tends to keep the flux constant. Assertion is correct, reasoning is correct, and the reasoning is giving the correct explanation of the assertion. So option A or 1 is correct. See, induction, self-induction is always opposes the cause, right? So it can also be called as inertia of electricity. So inductor is called the inertia of electric circuit. Reasoning is an inductor tends to keep the flux constant, right? So the option A or 1 is correct. Now question number 6. There may be an induced EMF in the loop without induced current. Induced current depends on resistance of the loop as well. So both the statements are correct. There may be induced EMF in the loop without induced current. Yes, definitely there may be induced EMF in a loop without the induced current. But the induced current depends on the resistance of the circuit as well. Since I is equal to E by R, right? It means current is depending on the resistance. And in an open loop, there may be induced EMF, but there will be no current, right? For the current, there should be a closed path. And induced EMF तो ओपन लूप में भी आ जाती है, लेकिन जो इंड्यूस करंट होती है दैट शुड हैव द क्लोज्ड पाथ. सो बोथ assertion and reasoning are correct, but the reasoning is not giving the correct explanation of the assertion. So option 2 or B is correct. Now question number 7. Assertion. When magnetic flux through a loop is maximum, induced EMF is maximum. When the magnetic flux through the loop is minimum, induced EMF is minimum. See, induced EMF depends on the time rate of change of magnetic flux. It do not depends on the magnetic flux. So assertion is wrong and reason is also wrong. So there should be the answer or option D or 4. Right? And the fourth one, both assertion and reasoning are wrong. Now question number 8. Assertion. When a bar magnet is dropped in a vertical long hollow metallic tube, the magnet ultimately moves with zero acceleration. This is the tube, metallic tube, and a magnet is falling through it. Let it is north pole and it is south. It is dropped vertically long hollow metallic tube, right? So its acceleration becomes 0. It is the assertion. The magnet falling into the metallic tube causes the eddy currents in the metallic tube. So the motion of the magnet is damped. The reasoning states that when the magnet falls, the induced current, eddy currents develop in the tube, which damped the motion of the magnet. So assertion is correct and reasoning is also correct, right? And the reasoning is also giving the correct explanation of the assertion. So answer A or 1 is correct. Option A or option 1 is correct, because in option A both are correct and reasoning is the giving the correct explanation of assertion. Now question number 9. The power output of a practical transformer is always smaller than power input. a transformer works on the principle of mutual induction. Right? The practical transformer have efficiency less than 1. Right? It means the output power is always smaller than input power. So it is correct. Now option reasoning states that the transformer works on the principle of mutual induction. It is also correct. But this is not giving the correct explanation of the assertion. Right? Mutual induction is the principle of transformer. Efficiency less than 1 is for practical, but it is not giving the correct explanation. So option B or option 2 is correct. So these are the questions related to the electromagnetic induction, assertion and reasoning base. Thank you very much.